Alright guys, welcome to this page of the notes. Now what we're going to do here is another problem dealing with rate of change. But this time it's not going to be for a problem where the rate of change is constant. If you remember on the previous page, we were filling a pool with water. And in order to fill the pool, you're using a hose. Since the diameter of the hose doesn't change, that means that the same amount of water will constantly be going into the pool, and we got a straight line graph, all right? Because the only way to change the amount of water going into the pool is to use a bigger hose or a smaller hose, and you're not going to change hose midstream. Once you pick your hose, you just keep going till the pool is filled, so we get a straight line graph. But what happens if we don't have a straight line graph? Well, one of the things I do during the summer is I am a lifeguard over at Disney, Walt Disney World, and I have lifeguarded before at the water park Blizzard Beach. Now, what put Blizzard Beach on the map is we have the tallest water ride in the state of Florida. It's a body slide. We call it Summit Plummet. This body slide is 120 feet tall, 120 feet tall. When you look up at it, it is miles high. In fact, because Florida is so flat, you get one of the best views I've ever seen from the top of this slide. You are way up there. You can see the Magic Kingdom, you can see Animal Kingdom, you can see practically all the resorts from the top of this slide. But it is very scary. You're 120 feet up there on top of this mountain, and it is practically vertical when you get to the middle part of the slide. Now the ride takes about 5 seconds. Only 3 of those seconds you're actually sliding, right? The last 2 seconds, because you reach about 55 miles an hour going down this slide, it is fast, we've got to bring you to a stop. So at the bottom of the slide, we have this long chute where we actually jet water back up the slide. So as you're coming down, you kind of run into that water going the opposite direction, and we bring you to a stop. But you're no longer coming down the slide. You are now back to level ground, and we just flattened you out, and we're trying to get you to come to a stop. So the last 2 seconds are actually us putting the brakes on for you. So what we're going to do is this is going to be an average rate of change because it's going to be changing. You start at the top of the slide, you're not going that fast. By the time you get to the middle of the slide, you are flat booking, right? And then when you get to the bottom of the slide, that's us trying to slow you down. So it's not going to be a constant rate of change. And in order to account for that, we're going to be looking for average rates of change, right? What is your rate of change over a certain period of time? Because it's not constant. This isn't going to be a straight line graph. Well, here we go. I ask you, using this chart, to go ahead and graph the function. So let me slide this up for you a little bit. I'm going to go ahead and put my graph right here. I need to leave it so that we can still see the table. And here we go. I'm going to freehand this graph. You can do the same in your notes. Here's what I need. I'm going to need a vertical axis. Now on my vertical axis, instead of y, I am going to have, right, height. It's going to be height in feet, so I will call it h. And that is going to be in feet. Those are my units. Now down here on my horizontal axis, I am not going to use x. In the x column, I actually have time, which will be in seconds. So we will call this t of s, the time in seconds. Well, that's going to be the easiest one. We're going 0 to 5 seconds. 0 is when you're at the top. We start the watch as soon as you push off from the top of the slide and you're on your way down. So when you're sitting up there at the top, 0 seconds, you're 120 feet in the air. You push off, I start the timer, and this is you descending down that slide until you get to the bottom. So I'm going to need 1 through 5 seconds down here on the bottom. That's going to be 0 right there. Let's call that 1. 2, 3, 4, and there's 5. Well, here's the easy part. I already know that 4 and 5, I'm going to be at a height of 0 feet. So we'll get to that. Let me put my scale on my vertical axis. I need to go to 120. I think the best way maybe to do it will be to go by tens. I think I can probably make that fit, by increments of 10 feet. So each hash mark will be 10 feet. I just got to make sure I put them close enough that I can get all the way to 120. Let's see how this goes. There's going to be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, there it is, 120. Let me label some of these so that we know where we're at. If that's 120, 110, 100, this one's going to be 90 right there. 80, 70, that one will be 60. Let's see, 50, 40, this one will be 30, and of course this one right down here will be 0. All right, so there we go. I've got my scale now on the vertical axis. It is in feet, and I'm going by increments of 10 feet. Let's plot my points. Let me do it with, I'll do these in red dots so you can see them. Let me make them a little bit bigger here so we can make sure we get a good dot. All right, here we go. My first one, I'm at time 0, and I'm sitting at the top of the slide, 120 feet. 0, 120, so we're going to be right up here. My next one is at 1 second. I have descended to 90 feet. So after the first second, you've descended down to 90 feet. Let's say it's right about there. That looks good. After 2 seconds, you've now descended down to 60 feet. 2 seconds, about 60 feet. Let's say right about there. Yeah, that looks good to me. 3 seconds, I'm now going to have to descend it down to 30 feet above the ground. 3 will be at 30. And then at 4 and 5 seconds, I am down here at 0. I'm going to go ahead and connect these with a line as best I can. Now, hopefully what you'll see, I'm not going to get a straight line to go through all of those points. It actually looks like the best way to connect these dots is going to be a slightly curved line. Let's see how this goes. Maybe if I come right through here. All right, it's not perfect. I missed that dot by just a little bit. Hopefully you can do a better job in your notes. Make sure you get through all those dots. But the point is, it's not a straight line graph anymore like it was on the previous page. It's now got a little bit of a curve to it. Because of that, that is going to change my rate of change. So here we go. Let's answer a couple more questions. The first one I ask you to do is I want you to find the average rate of change between 1 and 3 seconds. Well, let me do this. I'll do this in red. Come back up here. I need to find the average rate of change between 1 and 3 seconds. 1 and 3 seconds. Well, after 1 second, I'm at 90 feet. After 3 seconds, I'm at 30 feet. Remember, these would be my y2, y1, x2, x1. We'll go ahead and plug those into our equation down here. So here we go, my rate, let's call it AR for average rate. I'll abbreviate it so I'm not taking up tons of space here. AR, average rate of change, going to be y2 minus y1 over x2 minus x1. All right, here we go. y2, right? After 1 second, I'm at 90 feet. So that's going to be 90. That'll be my y2. That means that my x2 is 1 second, because after 1 second, I was at 90 feet. I'll subtract from that my second point, my x1, y1. Well, that's after 3 seconds. I've now descended to 30 feet above the ground. So y1 would be 30, and I have 3 seconds have elapsed. Here we go. 90 minus 30, of course, gets us 60. And 1 minus 3 should be a negative 2. And what we see here, 60 divided by a negative 2 should be minus 30 feet per second. Remember, the top, right, was height in feet. So I have feet in the top. The bottom was my x, or my horizontal axis, which was time in seconds. So I have seconds in the bottom, so feet per second would be my units. Okay, so what I see is on average, my average rate of change from the first second to the third second is about 30 feet per second. But what happens if I find the average rate of change for the entire length of the ride, from the top all the way to when they bring me to a stop at the bottom? Well, now let me do this one in blue. I am now looking at these ones. I need 0, 0, 120, and 5, 0. These are now going to be my points, y2, y1, x2, and x1. So let's go back down and see if we can calculate that. Once again, I'm going to abbreviate it so I don't run out of space here. This is going to be the average rate of change, AR. It's going to be equal to y2 minus y1 over x2 minus x1. Well, my y2, right? That's my very first point when I'm at 0 seconds, 120 feet up in the air on the top of this slide. Excuse me. So I'm at 120 feet. That occurs at 0 seconds. I'm going to subtract from that y1 and x1, which is going to be 5 seconds later when I'm at the bottom of the slide and I've come to a stop. So I'm now back on the ground. I'm 0 feet, but that took 5 seconds. So it's 5 seconds later. Well, here we go. 120 minus 0 is 120. 0 minus 5 would be negative 5. You go ahead and divide 120 by a negative 5. Don't fat finger something on your calculator. I get negative 24 feet per second. Now, here's what this means, right? If you're looking at just the time interval between the first and the third second, you're going about 30 feet per second. It's negative because you're coming down the slide, right? So negative 30 feet per second just means that you're falling. Well, you're not falling, but you're sliding down. If you take a look at the entire ride from top all the way until they bring you to a stop at the bottom over the entire 5 seconds, actually your average rate of change is roughly right around negative 24 feet per second. Again, negative because you're coming down. It would have been positive if you had been going up. The point here is the rate of change is not constant. It's changing depending on where you are on the slide, and so we have to talk about an average rate of change. That takes care of all the problems on this page of the notes. Head on over to the next page. We'll take a look at some more. I'll meet you there.